Hi everyone, in this video we will be having learning target number 3, which is to express the concentrations of solutions using different units. Alright, so when you talk of concentration, okay, we usually describe solutions in terms of their concentration. Okay, that refers to the ratio of the solutes to the solvents or to the whole solution. Okay, so solutions are homogeneous mixtures that consists of a solute and a solvent, and the concentration is a ratio of the amount of solute to the amount of solvent, which is given by small letter C, amount solute, over the amount of solution or the amount of solvent. So you can either report it in terms of the amount or either the mass of the solution or the volume of the solution or the amount, mass, or volume of the solvent. Okay, so that still refers to a concentration. Now, knowing the concentration of a particular chemical is very important so that we will be able to gauge and control its effects. Okay, so for example, a particular situation needs only a very dilute solution, meaning very small concentration, then we must be able to prepare that concentration, that specified concentration. So there are many applications, for example, in IV solutions in hospitals or in dosages, okay? Or we can have environmental standards. Let's say, for example, the amount or the how much lead, how many ppm of lead is allowable in a particular water sample. Okay, so those kinds of things can be reported differently. Okay, so that's why there is a need for us to study the units of concentration. Now we start with the basic ones. So in terms of percent, so we know that when you get the percentage of something, we just have to get the contributing value as our numerator. So for this case, it is our solute, and the value of the system. For example, if it's the mass, then you consider the mass of the solution, that is the solvent times the solute. So in here we have percent volume, which is equal to the volume of the solute, for example, in ml or in liters, over the volume of the solution, which is also in mil or liters. So just make sure that we can cancel both units, and then times 100. All right, or if it's percent by mass, then that is just mass of the solute, which is commonly reported in grams, over mass of the solution, which is also reported in grams, so that we can cancel then times 100. And don't forget also that in getting the solution, whether it's volume or it's the mass of the solution, you must add the solvent's mass or the plus the solute's mass, or the solvent's volume plus the solute's volume. Now, an extension of percent volume is also parts per million, which is similar to percentage. It's just that the factor that we multiply is times 10 to the power of 6 already, okay, because this represents a million. And then parts per billion, okay, especially for very dilute solutions, very trace amounts of solutes in particular solvents. So the factor there is times 10 to the power of 9. So it's just these guys here that are different from percentage. Okay, if it's percent, it's times 100. But if it's parts per million, then you count the number of parts times a million. Okay, or if it's parts per billion, that's the mass of substance A over the total mass of the solution times a billion, 10 to the ninth. All right, so parts per million and parts per billion are present in analytical samples, especially if you are given a particular species to, for example, analyze in a spectrophotometric equipment. Okay, it's usually in ppm. Okay, as for example, you want to know the amount of lead. Okay, so you prepare your standards, and that is in terms of ppm. So an example problem here will be, let's deal first with percent. Okay, so what is the percent volume concentration of a solution in which 75 ml of ethanol is diluted to 250 ml? When you say dilute, you add water such that the amount of the solvent will be much greater, okay, than before. Okay, that's adding water. Uh, so in here we have 75 ml of ethanol and the total volume is 250.0 ml. So this is now our volume of the solution. So what we can do is just to divide 75.0 ml with 250 ml but times 100 so that we can get the percent by volume. So that is 30% solution of ethanol. And take note that when you talk about COVID, the most effective percentage by volume for ethanol in rubbing alcohol is at least 70%. All right, 70%. But if there is also a top limit, because if we go beyond that limit, the ethanol will burn our skin as well. All right, so I hope you consider that in your performance task. What volume of acetic acid is present in a bottle containing 350 ml of a solution which measures 5% concentration? So this time it's the other way around. We are given the percent by volume, which is 5%, and then we are given the volume of our solution. What we have to get is the amount, or the volume rather, of our solute. Okay, so if you form your equation, that's practically x over 350 ml is equal to 0.05. Okay, so just move the decimal point twice to the left, so you just practically divide this with 100 so that you will end up with 0.05, and then you are given the total volume of the solution. What you have to look for is the volume of your solute, okay, x. And so when you cross multiply, that is basically x is equal to 0.05 times 350 mil. And then our x, the volume of acetic acid, is 17.5 mil. All right. Example number 3, find the percent by mass in which 41 grams of sodium chloride is dissolved in 331 grams of water. So our solute here is sodium chloride, 41.0 grams, and then our solvent is 331 grams of water. But is it safe to say that it's just 41 over 331? You're right, no, because you have to add the mass of your solute and the mass of your solvent to get the mass of your solution. So our equation now will be 41 grams over 41, which is the mass of sodium chloride, plus 331 grams, which is the mass of water, times 100. And in that way, we can get the answer of 11% sodium chloride in that particular solution. Okay? So there are other ways of expressing the concentration of solutions, which we will be dealing with in the next video. So stay tuned, but for now, you can take your stretch or do some nice workouts or take a cup of coffee or tea.